Hey guys, we're going to start on chapter 2 today, which is going to start with 2.1 operations with numbers. I think you might find this relatively easy, but this is sometimes things that I forget. We're going to first talk about identifying and use properties of real numbers right here, to evaluate expressions using order of operations, which, if you remember, is PEMDAS. Please excuse my dear Aunt Sally. So this might seem as a little refresher for you, but we're going to talk about different types of numbers. First, I wanted to talk about this little what is it called, Venn diagram thing kind of going on here. We have real numbers, and in real numbers, there's two different types of numbers. There's irrational numbers, which are kind of like decimals that keep on going on forever and ever, but cannot be put in fraction form. You can't simplify them. So and then there's rational numbers, and within rational numbers there's integers, and with integers there's whole numbers, and within whole numbers there's natural numbers. So a natural number is not only a whole number, but it's also an integer, and it's also a rational number. No, sorry, a rational number, whole number, natural number is a whole number. Natural numbers also could be integers, and natural numbers can be rational numbers as well. They are. So I'm going to give you some examples of these things here. I got natural numbers. Our example would be 1, 2, 3. Those are natural numbers. Think of those as your counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are all natural numbers. So that's what makes it a natural number. It's a counting number. Whole numbers are very similar. The only difference between whole numbers and natural numbers is whole numbers includes the zero. So right here, this area, that's just a zero right there. Everything else, 1 to infinity, would be a natural number and a whole number. Okay. Integers, or add a little bit more. When we talk about integers, we're dealing with not only 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but -1, -2, -3, all the way to negative infinity. So that's what an integer is. So integers are not only comprised of whole numbers and natural numbers, but they also have these negative numbers in there. Then we're moving on to rational numbers. Rational numbers are numbers p over q. Think of this where p and q are integers and q is not equal to 0. So what did Mr. Benson just say, you might be asking? Well, a rational number is any number that can be put in a fraction form. So think of it as 1 over 3. That's a rational number because you can put it in fractional form. Or 2 over 5. That's a rational number because you can put it in fractional form. Or 0.5, which is the same as 1/2. They're pretty much saying that any decimal that you could put in a fraction form is a rational number. Okay, so how do you know if you can put it in a fraction? That's what you might be asking. Well, if a decimal ever stops, if you have 0.25697 and it stops there, you can put that in a fraction form. Okay, this is 25,697 over 100,000. That's what that is. Okay, that's the fraction form of that. Okay, get rid of that. So if it ever stops, you can put it in a fraction form. Also, if it's a decimal and it doesn't, if it has a pattern, 257, 257, 257. See how there's a pattern to it? If it has a pattern but it goes on forever and ever and ever, because it has a pattern, you could probably put it in fractional form. So you can, not probably, you can. So if you ever see a pattern that goes on forever, or it's a decimal that stops at a certain point, then you know that it is a rational number. Okay, so that's the key there for that one. Then there's something called irrational numbers. These numbers are numbers whose decimal parts does not terminate or repeat. So it's a decimal that does not ever stop. So see, this one stops at 0.7. This one keeps on going forever, and there's no pattern going on it like this. 2.257, or 0.257, 257, 257. It would be something here. I'll give you an idea. Here's pi. Pi is an irrational number because it's 3.14159. Who knows what goes after that, but it goes on forever, and there's never a repeat in a pattern that keeps on going over and over and over again forever. So that would be an irrational number. There's other ones out there, square roots of 2 or maybe square root of 3. Those are irrational. A square root of 4 isn't, because square root of 4 is actually 2. So not all square roots are irrational, but those are some things you're looking for there. And then finally, we have real numbers. Okay, real numbers are all rational numbers and all irrational numbers. So pretty much real numbers are everything above here. this and this and this and this and this, those are just real numbers. Okay, so this is kind of just giving you an idea of what these different types of numbers are. I'm going to be asking you, is this number an integer, or is this number a whole number or a natural number? Those are some of the things you got to decide. Can you identify this as a rational number or a whole number or a real number and things like that? Okay, so hopefully this makes sense. In the next section, we're going to be starting talking about properties of addition and multiplication.